Let's look at the following example. Suppose a loudspeaker is capable of creating sound whose frequency ranges from 20 Hz to 20,000 Hz. Now, the sound level remains relatively uniform with an uncertainty of positive and negative 3 decibels. This means that over the given range of frequencies, the sound level of our loudspeaker does not actually vary by more than 3 decibels. So the maximum variation of our sound level of our loudspeaker is 3 decibels. So using this information, we want to calculate the maximum change in intensity for our loudspeaker. So we basically want to find the maximum intensity, the minimum intensity, and then find what the difference between the two is. In other words, by how much larger is the maximum intensity compared to the minimum intensity. So let's suppose that our minimum intensity I min is equal to I1 and the maximum intensity I max is equal to I2. Let's also suppose that at intensity of I1 at the minimum intensity, the sound level is B1, and at the maximum intensity of I2, the sound level is B2. And because the maximum variation is positive or negative 3 dBs, let's suppose that B2 is equal to B1 plus 3 decibels. So we're going to use this information in the following formula, which is essentially the equation for the sound level of our loudspeaker, to find the maximum change in intensity for our loudspeaker. So we essentially want to begin by finding the difference between B2 and B1. So B2 minus B1 is equal to, well, B2 is simply 10 log of I2 divided by I0. And B1 is simply 10 log I1 divided by I0. Now, notice the 10 appear on this term and on this term, so we can take that out. We get 10 multiplied by log of I2 divided by I0 minus log of I1 divided by I0. Now, by using our laws of logs, we can essentially combine these and divide these two terms. So we get 10 times log of this ratio divided by this ratio. So the I2 appears on the top, the I1 appears on the bottom, and the I0 appear on top and bottom. So that means we can cancel those out, and we get the following result. The difference between B2 and B1 is equal to 10 multiplied by log of the ratio I2 divided by I1. Now, what exactly is B2? Well, B2 can be represented in terms of B1 because we said B2 differs from B1 by 3 decibels. So we have B1 plus 3 dB minus B1. So these B1s cancel because B1 minus B1 is 0. And we get 3 decibels, or simply 3 is equal to 10 multiplied by log of the ratio I2 divided by I1. So notice we can bring the 10 to this side and we get the following result if we raise each one of these power of 10. So if we take 10 to the power of 3 divided by 10 and 10 to the power of log of this ratio. So this side simply becomes I2 divided by I1, and that is equal to 10 to the 3 divided by 10. So 10 to the 3 divided by 10 is approximately 1.99. So let's say it's approximately 2. So that means the ratio of I2 to I1 is 2 to 1. In other words, the minimum intensity differs from the maximum intensity by a factor of 2. And that's exactly what we were looking for. We wanted to find the maximum change in intensity for our loudspeaker.